Hello, my name is Lyudmila Rozova. I'm an associate professor of National Technical University, Kharkiv Polytechnic Institute, and I want to introduce your report on topic Information Technology in the Modeling of Dry Gas Seal for Centrifugal Compressors. The issues of computer modeling and information technology are very relevant in the study of engineering objects. They are the basis of computer experiment, which in most cases can be used to replace the implementation of expensive real experimental studies during finishing work in the process of servicing working structures. The implementation of computer modeling and information technology for the study of engineering objects is usually realized in two ways: by using existing technical software systems for general engineering solutions and by creating specialized self-software products. Of course, it allows to use more accurate mathematical models for analysis, taking into account processes and phenomena of different physical nature. So this advantage has created the need to develop a self-software package for modeling and solving of dry gas seals for the rotors of centrifugal compressors, which maintain gas pressure in main gas pipelines. And the aim of this work is to present this software package. Such dry gas seals have been widely applied in view of a number of advantages. The main ones are the possibility of operation at high rotation speeds for compressor rotor, the absence of an expensive oil supply system, minimal gas leakage during operation. They can work stably and reliably with various gases and under various operation conditions only in the case of very accurate modeling and solving. That is why the use of information technology for computer modeling of processes that take place during the operation of dry gas seals makes a huge contribution to the reliable operation of the system as a whole. The literature review on this topic has shown the relevance of this problem. Despite of a large number of publications on this topic, many issues of modeling and solving remain open. Many publications are devoted to the study. Only one physical process appeared during the work of dry gas seals. It is important to note that the main operational condition of dry gas seals is the existence of necessary gap between the seal rings with the thickness of near 3 or 4 micrometers in steady-state operations. The gap supported by the gas pressure and the necessary gas pressure between the rings in working condition is created and maintained due to the special type of microgrooves on the rotating ring with the depth of near 6 or 7 micrometers. In view of very small gap between the rings, it is necessary to take into account the temperature distribution in gas layer, seal rings, and the appearance of temperature strengths in rings. Therefore, the developed software package implements an improved methodology based on iterative solution of related gas dynamic, heat transfer, and thermoelasticity tasks for the dry gas seals under steady-state operation conditions. Let's consider the mathematical models of mentioned above processes. The distribution of gas pressure in the gap between the seal rings is described by the nonlinear gas lubrication quotient. The temperature distribution in the gas layer between the rings is described by the heat quotient. They formed the basis of developed specialized software package, which is called GasDIN. A special algorithm based on the use of Bubnov-Galerkin method in combination with the finite element method has been developed for solution. Because of non-linearity of formulated tasks, an iterative algorithm of their simultaneous solution has been developed. This iterative algorithm is carried out by developed package GasDIN. The conversion of huge analytical expressions of mathematical model were made using the package of computer mathematics. These expressions were automatically translated into the codes of C++ programming language. Thus, it was possible to avoid numerous mistakes. Analytical expressions were also used in testing to compare the results of calculations. This software package has been developed by use of C++ programming language. Block scheme and the main window of software package GasDin you can see on Figure 3. The main requirement for the service part of the software package was the creation of an on-screen menu with corresponding buttons allowing to manage standard set of work with the files and program modules, various forms of data input and output, visualization of results of solutions. It should be noted that the solution of heat transfer and thermoelasticity task, the visualization of obtained pressure fields and gas velocities are carried out using universal finite element software package. Data exchange between packages during iterative process is carried out by specially designed programs. The software package GasDin allows two types of gas dynamic solution at a constant temperature and not constant. The results obtained by gas dynamic solution are recorded to special files. The value of gas leakage through the seal resulting gas dynamic force are also calculated. After gas dynamic solution, the intensity of heat sources in the gas layer is calculated and exported into the database to solve the heat transfer problem. Further, the temperature fields of rings and pressures in the gas layer are exported into the corresponding databases for solving the thermoelasticity task. The calculation of the working gap, taking into account the obtained strains of seal rings, are also performed automatically. Testing of the created software package GasDin was carried out by solving test tasks for special cases which have an analytical solution, such as the distribution of gas pressure in the gap without groups, and it shows a good agreement with the obtained results. Also, test solutions were compared with solutions in literature and experimental studies. As for the real designs of dry gas seals, tested solutions using the iterative algorithm were carried out for the designs of dry gas seals used at the Joint Stock Company SUMI Machine Building Science and Production Association. Geometric and operating parameters of seal are presented here. A solution model contains groove and length. Groove and length with cyclic periodicity conditions. Gas pressure and velocity distribution for the seal with spiral grooves are presented on Figure 5 and with T grooves on Figure 6. Test results are in a good agreement with available in literature. To determine the strain state of seal working rings, three-dimensional ring models are used with the conditions of cyclic symmetry shown in Figure 7. The gas leakage obtained by developed software package is presented here. And it should be noted that the Joint Stock Company SUMI Machine Building Science and Production Association has created an experimental stand for study of dry gas seals. It determines the inlet and outlet pressure in seals, the gas velocities, and the temperature around seal rings, and gas leakage through the seal. The calculated gas leakage differs from the experimental value for the seal by 9%. It can be considered a good result. The heat transfer modeling for seal rings is done in axisymmetric setting. And the result distribution of temperature is shown in Figure 8. Experiments for studied seals showed that gas and gap heats up on average to 40–50 degrees in the absence of contact of surfaces. As a result of computer modeling, the gas at the outlet is heated up to the 46 degrees for these seals. That is in a good agreement. The test modeling and solving confirm the reliability of results obtained using the developed software package GasDin. Conclusions on work. The developed specialized software package for computer modeling of dry gas seals for the rotors of centrifugal compressors is presented. The software package implements the mathematical model that describes improved methodology for seal modeling and solving under steady-state compressor operating conditions. The developed software package has been tested on real constructions of dry gas seals with different types of grooves. The results of test solutions were compared with available in literature and experimental studies. Thank you for attention.